Hi, am I audible here? Is there any, let me just test my audio whether it is working properly or not.
Yes, ma'am. You are
Yes,
audible.
ma'am.
Okay, thank you. Thank you so much.
Good morning, everyone. We'll start the meeting within couple of minutes, waiting for our guests to join the meeting. Good morning, Pranita ma'am.
Good morning. Good
Yeah,
morning, Vasudha ma'am.
yeah. Just hold on. Let me switch on my. Yes, yes. We'll start the session, right, ma'am?
Yeah, no problem.
Yeah. Okay. Uh, Good morning, everyone. Respected dignitaries, esteemed faculty members, distinguished speaker, and dear participants. Today, on behalf of Dr. D.Y. Patil Unitech Society, Dr. D.Y. Patil Institute of Technology, Department of Computer Engineering, I, Mrs. Vasudha Faltankar, along with my colleagues, Dr. Dhanraj Dhotre sir, Mrs. Bharti Sahu ma'am, welcome you all on this second day of 1 week faculty development program on AIML in healthcare and medical informatics. It gives me great pleasure to introduce our distinguished speaker for today's session. Please join me in welcoming Dr. Pranita Mahajan, Senior Data Scientist, Health Operations, Relics Elsewhere, India. She is data scientist professional with 17 years of academics and the industry experience in machine learning, deep learning, data analytics, NLP, and the knowledge graph. She is proficient in understanding business and the data to build use cases and analytical solutions that solve the business problems and drive actionable insights to drive customer success. Thank you, ma'am, for accepting our invitation. And over to you, ma'am. Thank you.
Thank you. Thank you, Vasudha ma'am, for such a kind introduction. So good morning, everyone. I'll quickly share my screen and would like to know if the screen is visible. Is it visible? Can you see my screen? Is my screen visible?
Yes,
Yes,
ma'am.
visible.
Okay, great.
Yes.
Yeah, thank you. With immense pleasure, thank you, Dr. Dhanraj Dhotre, Vasudha ma'am, for inviting me, giving me this opportunity to interact with everyone. And this would be a kind of discussion today. And yeah, so good morning. So I will be talking about the retrieval augmented generation today. So before diving into RAG, I'll introduce you to LLM and few basics of LLM which may be needed to understand how the RAG works. So I'm Pranita Mahajan. I hold PhD in natural language processing from SPNIT Surat and currently working as senior data scientist in health operations department of elsewhere. So today for our talk, I would like to discuss what are large language models, how can we train, which all different techniques are there with which these large language models are trained basically, how the LLM works under the hood, which all types of LLMs are there, fine tuning LLM, which methods of fine tuning are there. So this much topic, I'd try to just give you a quick introduction of it because now being in this tech field, we all are quite aware with what are LLMs, and we are using it in our day-to-day lives as well. So I'll be focusing more on how the RAG architectures are built, what are vanilla RAG architecture, how can you improve the RAG basically, and then I'll take you through quick overview of what are better ways of prompting because that is very much important when we are um, inferencing or when we are using any LLM, it can be for agents, building agents, or it can be for building a RAG as well. And then how, and the most important part of any application building, which is evaluation. So which all methods are there with which we can validate either our RAG architecture or any application which we are building basically. And a uh, quick, uh, I'd say, introduction of AI agents and responsible AI. So I'm not gonna take you into what are AI agent. It is just a door which will open basically after this presentation for the session which is already planned in your FTP for last day basically. So there you are going to dive deep into AI agents and how we can use these models responsibly. Yeah. So to start with, nowadays we are all using large language models in our day-to-day life. There is rarely anyone in the tech field, non-tech field for that matter, who are not using ChatGPT or any other large language models in their day-to-day life. And our exploration is not limited only to the text, but we are also experimenting with images and videos and whatnot kind of data using these LLMs. So basically, these are the advanced AI systems which are trained to understand um, the human language and not only understand but also generate the human level language which can answer the questions, summarize the documents, and there are so many works or tasks which can be performed using these models basically like object detection, image questioning, captioning, sorry, or question answer generation, classification, any kind of analysis. Nowadays we have seen that there is a lot of research going on in the vision models or the multimodal models as well, which talks about images, audios, and video type of data. So when we are talking about LLMs, basically there are three phases of training these LLM models. First phase is pre-training, instruction tuning, and fine-tuning. So whenever, like, at least this was the question in my mind when I started using ChatGPT, that how come it is understanding everything? How come it is understanding every domain? And how come its knowledge base is that vast, right? So the answer to this question lies in pre-training. These models are basically trained for next token prediction. So the task here is not any complicated task. The task is very simple that, hey, predict the next token. So during the pre-training, what will happen? The raw data is dumped into these models. I'll be talking here at very abstract level. It is not as easy as that dumping the data here. Um, so this raw data, a huge amount of raw data is taken and it is given to the model and it is unsupervised training or learning, we can say. So here the data will be taken during the training phase and it is learning only next token prediction. So let's say when I'm saying thank, now this data is uh, this data has seen so many sentences with you after thank. So now it knows that, okay, you should be predicted after thank. So this is during the pre-training, the task is next token prediction. Now, but we have seen that these models are also able to answer the questions which we are asking. That means it is not just a token. It needs to go something. It is not just unsupervised training. It has to go something beyond unsupervised training, which is nothing but instruction tuning. So during the second phase of large language models, the supervised training happens here. So this, which is called as instruction tuning. During instruction tuning, question answer pairs are prepared, and these pairs are fed to the model for training purpose. Now model, which has already understood the language nuances, the language complexity, is also able to that predict that what should be the answer to the given question. So this is called as instruction tuning. This is supervised training approach, wherein there is a question, there is an answer, and for a given question, what kind of answer should be given, right? So now, when I'm saying question answer, so what do you think? Do you think that these answers, let's say, like I'm asking a question that, hey, give me how heart functions in the human body. So if I'm asking this question, and if you are also asking that question, the answer is not going to be same, right? I hope you all agree with me that the answer is not going to be same here. It will give you different answer for the same question. And this is the non-deterministic nature of these models, because these models uh, are trained for the purpose of language generation. So when it is generating the language, it is not simple encoder model, or it is not just a encoder decoder model wherein it is being trained on the data set and it will try to imitate what this data set is doing. So during the instruction tuning, whatever data set I have used, that data set will help understand model instruction following capability. So during pre-training, the model is understanding the next token prediction capability, and during instruction tuning, model is learning the instruction following. Sorry, is there any is there any question? There was someone raised, or probably someone was saying something. Any question? May I continue? Okay, super. So if there's no
Yes, yes.
question, I'll
Yes,
quickly
continue.
take it.
Please continue.
Okay, thanks. Super. So during instruction tuning, it learns basically instruction following capability. So if I'm asking a question, hey, how heart works, and please tell me from the fifth grader perspective, how the human heart works. For both the questions, the answer is going to be relevant to the question. So the answer which will be predicted or generated by the model for fifth grader will be considering that fifth standard student persona. And that is called as the training which has happened during the instruction tuning. Because of that, now model has learned the instruction following capability. That the instruction there is scientifically, if the general instruction is given, it will give you general answer. But if a specific instruction is given that, hey, tell me how heart works from the fifth grader point of view, then it will simplify the complexity of the scientific complexity of that answer, and it will restructure and regenerate that answer in such a way that it will be understandable to fifth standard student, right? Now during the fine tuning, later came the era where I saw that, hey, people are not only using chat gpt or these large language models, for that matter llama, mistral, but they are also they are also training these models to perform particular tasks. Like for example, there can be a health related question answering model wherein it is answering questions from health domain. So in that case, it is doing something other than instruction tuning, something better than instruction tuning, and which is nothing but fine tuning. So during fine tuning as well, these models are, this is a supervised training method wherein question answers same as that of instruction tuning. The only difference is during fine tuning, the domain specific question answers are fed to this model. And now model here is learning domain specific knowledge. Like here, it can be legal, healthcare, finance domain, or it can be, let's say, only relation extraction task, or it can be named entity recognition task, or it can be something very specific or niche task which the generic model or the instruction tuned model is not doing good, but you have a data in your hand with which you can feed that knowledge on top of it. So during pre-training, I can give you the analogy here that during pre-training, it's like a kid who is in nursery, senior KG or junior KG who is learning English language. Just next token prediction or understanding the complexity of the language. During instruction tuning, basically a student who is from 1 to 10 standard, a generic knowledge, instruction following abilities and understanding again the language is able to converse and identify the intent of a user. During fine tuning, probably we can say that it's a student who is into commerce stream or into science stream or into medical stream and so on and so forth, right? So with this analogy, we can better understand these three phases of LLM. Now, this is what I have explained basically. So now, but where it started, like what is now we are engineers and we are not just we just want to use these things which are available. We just don't want to use these models, but we also want to understand that what are the fundamentals behind these models, why these models are so intelligent, so that if I want to build something like this from scratch, what should I use? What should I know? So basically, under the hood, the LLMs are able to achieve these remarkable capabilities because of the combination of deep neural network architecture. And we all are very much familiar with attention is all you need paper, 2017-18 paper, which was like a kranti in our tech field. And we saw that the transformer models were doing wonderful. They were understanding much beyond the data set which we are using. So way better than the deep learning models, specifically for the natural language processing and image processing kind of task. Why? Because these models are having, or this architecture is having these three unique and vital components, which are like attention. So this attention mechanism is because of the attention mechanism, to put it in very simple words, the architecture or the model understand that which words are more important in the sentence. Like in NLP, we do stop word removal and everything, and then we extract the entities and we say that entities are my features because these are more important. So the attention layer or mechanism works in that way in the transformer model. And then, but then now the models, the encoders or the simple transformer models, which we have seen earlier before 2018, these models were not able to understand the order of the data. So, and sequence is very important in NLP. Basically, whenever we are working with the text type of data. So to understand the order of the sentences, like when I'm saying thank you, you should come after thank and not before. You thank is not a good ordering. So for that purpose, the next component, which is positional encoding, which is added to the embedding of the text which gets generated by the encoder, so that it understands the sequence structure and the context of the input which is feeded for training purpose. And then of course there are feed forward neural layers and layers of feed forward neural network depending on the complexity of the task for which you are training the model, which are actually fully connected layers and with nonlinear activation functions, so that it can capture the complex transformation and the data. So basically, these are the three components which are quite vital, and because of which we can say that the LLMs are, achieving the remarkable capabilities which we see nowadays. So when we are building it from scratch, we need not uh, worry about that. Okay, is this something new? No, it is the old wine in new bottle. These are the transformer models which we have been using since long, right? And we can build our own LLM from the scratch if we are very well aware with the transformer architecture basically, right? So now when this is how it works fundamentally, or at the base, at the hood, what is more important when we want to build something like this from the scratch. So but then which type of model I want, the question mostly, suppose we have a problem statement to be implemented, and I want to know that which model will be suitable for me, whether I shall go for the pre-trained model or instruction tuned model or a fine-tuned model. So this slide will answer that, help you basically make that choice. There are base models, there are chat models, there are instruction tune models and fine tune models as well. So base models, something like GPT or Llama or Meta based model or Palm, Google's. These are very I can't say old. 2 year is actually not old, but because of Gen AI evolution, we can say that okay, these are quite traditional and old models which are available, and these models are pre-trained model, base models, so only the next token prediction is possible with these models. There are chat models with which you can build a chatbot kind of things. Instruction tune models, as I explained earlier, herein instruction following capability. So if you want to build a chatbot, or if you want to build an application for kids, or if you want to build an application, let's say only for breastfeeding mothers, or if you want to build an application for science graduate, so you're talking about quite niche domain here and quite niche user here, then in that case, your instructions are way different than that of the generic instruction. So it is better to use the instruction tune model and have your own instruction tune data set which is tailored to your user requirement, and then you can instruction tune the model and use it as a fine-tuned model as well. When it comes to fine-tuning, so these models are fine-tuned, like how we used to fine-tune BERT is being fine-tuned to SciBERT or MedBERT. So the encoder models, the concept is same here. You will use the base model, which can be a base model or instruction tune model. You have your own data set, and now you are fine-tuning that model so that it will be able to perform the generic task for which it is trained. Like, for example, if you ask a question to a eighth standard student, the answer which is given by that person, and the syllabus, you are asking the question only from the syllabus which is still eighth standard. So the answer which is given by eighth standard student, and then you are asking the same question to, let's say, engineering student, definitely there will be a difference in the answer, and that because the engineering student's knowledge is fine tuned with the knowledge which he or she has gained during his professional degree course, right? So fine tuning will do something like that. It can be a single task or it can be multiple tasks. So like named entity recognition, I want to fine tune it only for named entity recognition, or I want to fine tune it only for relation extraction, or only for sentiment classification. Or you can say, no, I want this model to perform relation extraction, named entity recognition, and some other classification as well. So that is called as a multitask model. So for that purpose, you need to work a little on the data so that model will understand and we'll be able to bifurcate in the data, right? So without entering into too much details of fine tuning, I'll quickly take you through what is the difference between the conventional fine tuning and parameter efficient fine tuning. Because there may be a question that I don't have those many resources. These models are huge, 7 billion, 13 billion nowadays, like a huge models are there. So how can I fine tune it? I don't have the GPU power. So the solution is you can use parameter efficient fine tuning, wherein the original weights of the model will remain frozen, and you can add and fine tune additional parameters. I have even worked with encoders. I just attached one encoder and I updated only the encoder parameters. And that model was also working fine for the domain specific task. So not only updating the last layer of your transformer and updating those models, but also you can add an encoder layer on top of it, and it that also works fine here. So basically, when it comes to fine tuning, you can, as I said, you can use adapter method, or you can use prompt tuning that use the model as is through the API and add a virtual token, which will identify the start and end of the question. And then during the training, only the virtual token embeddings are updated, and the base LLM, the entire LLM remains frozen. So it needs very less GPU, 4-bit GPU, even a Colab notebook is sufficient. Today, I'll walk you through the demo which I have prepared for the same. And then there are RLHF as well, wherein you want the feedback to be taken from the user, and then it should update the parameter again. So this is a quite a huge field, which will again need a lot of time to discuss. So quickly, I'll introduce you to these methods which are there. And the very much popular method, which is nothing but inferencing as well, like people just opening the chat GPT and firing a query there. So this is called as LLM inference. But being a technical person, we should understand that when I'm inferencing the model, there are other parameters along with this. So I should be able to control these parameters as well, so that I can use this model better than that of the users, which are probably not from the field, technical field, right? So of course, the question which we are asking is a prompt. There is a temperature which controls the randomness. Higher the value of temperature, more diverse response, more creative response will be there. Lower the value of temperature, more focused and repetitive or factual response will be there. So when temperature value is lower, your model will adhere to the training data, and it will predict, it will generate the language which is in sync with the language which is used while training the model. Whereas if the temperature value is set to high, zero point 0.8, zero point 0.9, then the language which will be used will be more flourished. And when it is trying to use more flourished language, it may deviate from the original factual data, and it may tend to hallucinate, right? So finding the balance for the the temperature parameter is also one skill in prompt engineering, basically. Then there is top P, which will limit the generation to the top probability mass P. So here it doesn't talk only about one probability, but it talks about the cumulative probability. So when I am saying I am standing at the river bank and taking a walk. So here the probability to predict walk token, uh, the probability of I am standing at the river bank. So the entire cumulative probability will be calculated, as opposed to top K, wherein only the last token's probability is being considered. Top K, top K tokens are considered last three, last five. Whereas top P will consider the cumulative. So it will give you more focus, creative, and also more relevant to the context answer, right? Now the repetition, if you are setting lower value to the temperature, the model tend to repeat the sentences in the response. You would have noticed this. Particular words will be repetitively used. I'm fortunate to be here. This is fortunate. Sometimes such phrases are repetitively used by LLM. So you can penalty this by setting up the penalty repetition penalty parameter in the parameter setting. But you will have to use it through API only. Like you need access to the model and use it through API. Then only you are able to play with these parameters. And the other is context window, of course. So larger the context window, you can have larger questions, and you can expect larger response from the model as well. Just remember, the context window is actually the input plus output. So if your question is too large, it is actually eating the space of the response as well. So in the prompt engineering, it's a skill to ask optimized questions as well, right? So what do I mean by optimized question? How can I intelligently ask a question? And it is called as asking right question. So it's a 5 principle rule actually. Give direction, specify the structure, provide some example, one shot, few shot, zero shot, evaluate quality in the prompt itself, and divide the labor. So I'll give you one example. Uh, something is no problem. So I'll give you one example. Summarize below text to include all important key topics in document. So I'm giving direction. Generate the summary to be understandable to non-finance users. So I'm specifying the structure, I'm specifying the format, I'm defining the persona of a user. The summary should be consistent and only from the input text. So again, a structure and format is being enforced here. If the document is too long, then split the document according to the key topics discussed and then summarize. So I am dividing the labor, and see the example for reference. So I'll give one example, which will be probably one shot, right? And then input text will be given, some example will be given, output format is mentioned. I am also specifying the quality of the evaluation. That summary should be consistent, and it should be only from the input text, right? So when you are applying this 5 principle rule, the question which you are asking is optimal. Apparently, it will help model understand your question better and give you more robust, more quality response, basically, right? So when you have such a specific instruction, you can control even the non-deterministic nature, and you can expect that most of the time similar response will be generated by the model. So this is a 5 principle rule which is used in prompt engineering. Uh, so there are many type of prompting technique. I'll not get into it because it's already 11. I'll be sharing this deck with the committee, and you can go through these techniques. The one which I loved the most, and it actually changed the game in my organization, is negative prompting, where we try to control the hallucination by telling model what not to do. So we were building an application for summarization, and it was hallucinating a lot. Even if the text is not there in the paragraph, it was just generating, because these models are trained to generate, right? So it was simply generating the text and hallucinating. So we told model that, hey, do not use the text other than the text from the input sentences or input paragraph. So what not to do when it is told clearly to the model, then you can control hallucination to the extent, right? How will you evaluate something in the message? Okay, not for me, no problem. So how will you evaluate, these models? So there are metrics, quantitative metrics are available, like Rouge, blue scores are good for summarization. Perplexity is very useful for evaluating the quality of the text which is being generated, whether the text is coherent, consistent. There can be human evaluation, human in the loop. You can use LLM as a judge. There are frameworks like ragas which you can use, and there are multiple frameworks available which can be used, like Glue, Superglue, Math Benchmark, GVal, BERT scores. These quantitative metrics are also available, which you can use to evaluate the response which is generated by your model. With my experience, we experimented a lot with LLM as a judge, and we are having really good outcome with that. So this is all about introducing you to large language model. If there is any question, I'll be happy to take, or we can move to RAG. I'll introduce you to the vanilla RAG here, and then we'll move towards how we can improve it further. I'll quickly check the messages. Nothing. Okay, nothing in the chat. Okay, so if there are no questions, we can move further. And now, what are retrieval augmented generation? That is RAG. See, let me tell you first the need of RAG. If suppose you want to build an application for your university, for your college. Suppose I'm teaching, let's say, DSA. And when I'm teaching data structure to the student, I have noticed that few of my students are not performing well in stack. They didn't understand the stack concept. Few students have not understood the queue concept. Few students are confused even at the pointers, which is very introductory, right? They are not understanding searching, indexing. So it is very difficult for me to be available for them 24/7 to solve their doubts. So what will I do here? And I want it to be very specific to data structure, right? I do not want, and I also want it to be specific to the notes which I have used to teach them, right? Because data is available everywhere on the internet, but I expect them, I'm very much confident with the notes which I have prepared, and I want my students to get their answers only from the notes and slide deck which I have prepared. So what will I do here? If I fine tune, then there is a lot of effort needed to convert these documents into data set, which will be useful for supervised learning. So I'll have to have a data, and a lot of work is there, a lot of pain is there basically. So what will I do? I'll use a RAG architecture. In the RAG architecture, you can use your own documents and you can feed it to the model. Now, model will give preference to your document which you have fed. And if the answer is not found in your document, then it will try to search uh, from its own knowledge repo. So here, what will I do? I'll feed all my data structure nodes here. Okay. And I'm gonna take you through a Colab notebook wherein we will be actually doing so. And then from those PDFs, I want the model to answer the question. So when user will ask a query, the answer will be only from my notes. So here the RAG architectures play a vital role and work like a champ, wherein you can rely on the response, and you can assure your client or user that, hey, the answers are coming from the trusted source, because these LLMs are trained on the free data which is available on the internet. We don't know how much factual these answers are. I can't trust whether I can trust these models or not. So to give that assurance to your client, you can build your RAG architecture. So I'll take you through a vanilla RAG first and then the improved RAG architecture. So in the vanilla or the traditional RAG architecture, I'll quickly move this. Yeah. So in the traditional RAG architecture, context is all you need. So till now I was talking about attention is all you need, right? So now context is all you need. And the context is my DSA notes. The context is suppose I'm a doctor and I want to see my XYZ patient, what is his or her medical history. Then in that case, uh, I do not want that data to be shared on the internet because it's the personal data of my patient, but I still want, something very quick, so that instead of reading all my 1,000 patients, a model should read all the 1,000 patients and answer me. I'll say, Mr. XYZ, can you give me Mr. XYZ's medical history? And it should be able to answer. And of course, ChatGPT or any other LLM will fail in doing that because that data is not available with them, isn't it? So here, what will I do? I'll use all my patient records and I'll ingest it to the model. So ingestion is the first component wherein you will take all the PDF documents, and as we have seen that there is a context window. So the context is limited here. As the context is limited, the entire record cannot be used, right? I have 10,000 patients, so 10,000 patients will not fit into single context. So I'll have to split those records into chunks. Okay, it can be paragraph level chunking, it can be sentence level chunking, token level. There are many different methods of chunking which we will see later. So I'll split those documents and then I'll encode it. Now for encoding, I'll use an encoder. Now when I'm choice of encoder is based on for which domain you are building this pipeline. So if I'm building it for healthcare domain, then I'll use, let's say, BioBird or SciBird or PubMedBird basically. But if I'm using it for financial, then I'll say FinBird or any other encoder model which understand that domain well. Right, so here we are using only encoder. The embeddings will be generated by the encoder, and then we will store it into the vector DB, a phase or a chroma DB. Today we'll be using a chroma DB in our uh, implementation basically, which I'll share with you. So in vector DB, these chunks will be stored, which are apparently converted into vectors. Now will reside here. Now we'll go on the other side. Now user is asking a question. A doctor says, hey, Mr. XYZ, give me his medical history. So that question will also get encoded. The vectors embeddings will be generated. The encoder which you have used to process the encode the input document, and the encoder which you will be using to process the user query has to be same, because apples can be compared with apples only, right? So the encoder has to be same here, and then the embeddings will be generated. Now the question embeddings will be taken, and it is simple cosine similarity. It is as simple as that. Simple cosine similarity between the question embedding and the chunk embedding. Now top K, top P, which I was talking about. So here it will, the cosine similarity will give you top K relevant chunk. Those top K semantically similar chunks will be retrieved. Okay, and then this is done by the retrieval model. This will be retrieved and now it is given to LLM. So till now there was no LLM in question. So the knowledge base, you can see this is my knowledge base. The knowledge base is completely built. The context from the knowledge base is completely built by an encoder and not by LLM. So there is zero question of hallucination. And the data is retrieved only from the input documents and no other knowledge source here, right? So now here, the context, that is the top key relevant chunks which are retrieved, will be taken, and now LLMs comes here. Now why we need LLM here? Because we want it to be user understandable response, right? It should feel like human is communicating with me. So these chunks will be taken together, and now here again there is another vital component, which is prompt. Okay, so in the synthesis uh, phase of this pipeline, your prompt engineering techniques plays a vital role. You need to write a prompt which is specifically tailored to the use case. So that I'm a doctor, these are my patient histories. I want to search for the most relevant patient record from the for the given question. Kind of prompts you'll have to use. So these prompts will be tailored to the use case which you are trying to build, and then the answer will be generated. So very simple architecture, very easy to build architecture is there when you are using RAG, and it works wonderfully specifically for hallucination. So now I have explained you each phase, but quickly, like chunking, wherein we are splitting different type of so here we are splitting the document. Different splitting techniques are there, like there can be fixed size chunking, context aware chunking, naive splitting, recursive chunking, which is quite popular. And I have even experimented with context aware chunking, which is my own technique. So wherein it these with these technique, basically you try to split the document. Why we need to be worried about the splitting? Because when I'm saying that split it sentence by sentence, so it may happen that two most relevant sentences are splitted in different chunks, right? And the first chunk in top key relevant chunk, the first chunk will be there, but the second chunk will not appear at all. Why? Because my chunking strategy was not good. So fixed size chunking may not work good. Context aware chunking works really good, wherein you're saying that from all these documents uh, put together semantically similar chunks. So maybe patients who are suffering from, let's say, lung disease will be put together. So if I, being a doctor, if I ask a question that, hey, from my previous prescriptions given to my patients, can you guide me to treat Mr. XYZ who is suffering from this blah 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 symptoms? Can you guide me what treatment was given by me to earlier similar patient? So in such scenario, context aware chunking should be a suitable option here, because it will split the document based on the semantic similarity, right? So semantic similarity means semantically similar patients would be there, and then it will be also able to answer questions like this. So basically, you are trying to train a doctor's mind here, right? Naive splitting, wherein just use spacey or just use /n to split, or any naive technique. So this is useful when you are building something like FAQ, frequently asked questions, a chatbot, something like that, which is customer facing. A naive splitting works there, because this is gonna eat much of your tokens, right? It is gonna eat much of your context. So you need to be very cautious while selecting the chunking technique. This is good and should be used everywhere. Is not There is no one T-shirt which fits for all. So naive splitting will be useful when you are working with FAQ type of chatbots, wherein your answers are very short. Okay. And recursive chunking is the one which is quite popularly used in LangChain. A character level recursive techniques are used, which will split the documents into chunk. And when it is splitting the document, it will make sure that two chunks will have some relation between each other by overlap. So if 100, let me. So when I'm chunking this one document, okay, this is entire document, and I am yeah. So I'm chunking it into, let's say, 3 chunk. So when I'm performing this chunk, then there will be a overlap. So overlap will be like something. This much text will be common. So if I'm saying 1500 is my chunk size, 1500 tokens is my chunk size, I'll say 100 is a overlap size. So 100 tokens in both the chunks will be same. So because of which, what will happen? now it knows that which two chunks are relevant to each other, which two chunks are closer to each other. So when it is selecting top K chunks here, then because of this overlap, it will be able to select most relevant top K chunks for the particular question, right? So this is about chunking. For embedding, as I've told you, variants of BERT, many flavors of BERT are there. You can use sparse embedding like TF-IDF, which may or may not be useful. If you are more into language generation, my suggestion will be not to use anything like TF-IDF or doc2vec or what2vec, because these are not suitable for language generation. Okay, suitable for language understanding, but not suitable for language generation. And you can see that there are many embedding encoder our embedding model encoders are available on this link. So in the deck, this link will also be shared with you. Okay. Now the third component for indexing, you will index the document so that the retrieval will be faster. Otherwise, you ask a question and the answer comes after 4 hours. So doctor will say, instead, I'll read my patients all the records which are with me, right? So we need to index it. We know elastic searches are there. There are many other indexing techniques with which we can have a faster retrieval. There are vector databases like Pinecone, ChromaDB, Phase, Snowflake, and Elasticsearch. They have come up with their own RAG frameworks as well nowadays. I have uh, very positive experience with Phase for a smaller application, and very positive experience with Pinecone for application which is in production. Because this is paid, it will give you very less space with a free version. ChromaDB also works well with larger application, but if you want the application to be in production, then it is better to use Snowflake or Pinecones or Elasticsearches basically. So these are the vector databases, and the retrieval which I told you earlier. So this is our retrieval wherein context is fed, and now I'm using LLM to generate the response. So there are again different ways with which the retrieval works. I'll discuss two ways here. One, the naive or the standard approach, wherein documents are taken, chunks together. Okay, embeddings are stored. The chunks are stored in the vector DB, and then the same text chunk used in embedding and synthesis. So these are the chunks. Let's say top K chunks. Let's say top 3 chunks are being retrieved, and these 3 chunks will be used by LLM, and LLM will answer only from these 3 chunks. There can be relevant information in your vector DB, but it failed to get into top 3, and that's why it is not there, right? So there is a second technique which says that instead of having a larger chunk which is hampering the relevant information to be not there in the synthesis phase, so instead of using that, you experiment with little smaller chunks. Okay, now if the chunks are smaller, you can have the chunks around the chunks in the context. So when I'm saying that top K, I'm retrieving top 3 chunks here, 1, 2, 3. Top 3 chunks are being retrieved, but here what I'm doing, I'm going back to this slide. Yeah, so this was my one chunk. Okay, so from some other document, this was second chunk in top K, and this was third chunk in top K. So if I would have been using the naive technique, only these 3 chunks will be there in the synthesis phase. But if I'm using a improved technique, which is sentence window retrieval technique, herein what will happen? This 3 context aware. So this third chunk will go along with these 2 neighboring chunks. This one chunk will go along with these 2 neighboring chunks, and this will also go along with these 2 neighboring chunks. So even if I'm selecting top K, so top 3 chunks I'm selecting, but at this still I am having much more information than this. So you may say, you may have a question here that, hey, but then it is eating again lot of token space, right, during the inferencing. So when should I do this? So here, when your documents are large, when you are querying, let's say, book chapters, let's say there is a book on data structure or book on medical, let's say cardiovascular diseases, and you want to retrieve a particular information which is spreaded across the book. right? So in such situation, it is better to use these techniques wherein your data is really large in size, right? So this is how the retrieval can be used, and it can be improved as well with the context aware or sentence window retrieval technique, right? Now there is a re-ranking. In the re-ranking, what happens? It has retrieved these three top K chunks, but not necessarily that these three top K chunks are in the same order. To give you an example, I may say that let's say there was thank word here, you word here, and forward here. Okay, just an analogy basically. So now if these three are going in order, then thank for you is going there, right? So we need something which will reorder these chunks based on the coherence and consistency. So re-ranking phase will perform re-ranking, semantic re-ranking. Sometimes it is lexical re-ranking, and different methods of re-ranking. There are models which can be specifically used only for the re-ranking purpose, which are available on the Hugging Face as well. So here it will basically re-rank, and the chunks which were 1, 2, 3, which was this order, now it will be re-ranked, and the order will be 1, 3, 2. So thank you for, right? So this is how the re-ranker will work. And quite abstract level, I'm telling you, it is not as easy as I'm telling you. It is a quite complex operation. And in the last phase, now here the LLM enters. Now here LLM will take those most top key relevant documents. It will pass to the prompt, and how intelligently you are writing the prompt. Based on that, it will generate the response, and then that response will be given to the user basically, right? So the document is taken, embedded, stored in the vector store. Relevant documents are retrieved, chunks are retrieved, query is taken, that is also vectorized. The context is built from the document, and question is given by the user. This dictionary will store the context and question. It will be fed to the prompt template, and then LLM will answer, right? So this is sorry, excuse me. So this is how the RAG architecture works in detail, basically. And if there are questions, I can take the question, or we can move further. Or do you think any comment on this? That do you think that this will control the hallucination problem of LLM, and how? Will is there anyone? No pressure. Is there anyone who wants to answer? Please.
Hello.
Yeah.
Hi, Pranita. So as you have mentioned, I have one question and I will answer the question that you asked. But my question is, first of all, I will ask you my question to you.
Sure.
You said, it's like a closed loop model, which will answer based on the specific data set that we are providing.
Yeah.
But like somewhere, the role of LLM is like limited to answering the queries based on the selected, say for K chunks, right?
Yes. Yes.
But like somewhere like RAG is at the top of the LLM. For example, if the GPT framework. So along with the external information, this RAG help us to answer the queries based on the selected information. So how it like happens?
Yeah.
How the LLM is uh, playing the role while retrieving the answer based on the selected documents, as well as taking the external inputs apart from the selected data.
Yeah. Yeah. That's really a great question.
And the question and answer for your hallucination
Sure.
is like as you said, like it's based on the selected information. It retrieves the information based on selected information, and the role of LLM is like at the prompt level only, not at
Correct.
the retrieval level. So hallucination, there
Okay.
is no question of hallucination.
Exactly. Yeah. Yeah. And you have done that. Then sorry.
Yes,
If
go
I
ahead.
couldn't see your name, sorry, but with the voice,
Dhanraj.
as I know, I could get that it is you who is asking the question. I couldn't see the name. Yeah. So in your answer, there is an answer to your previous question. So I'll just try to elaborate that.
Yes.
So thank you so much for answering this. So here the question is that how it is working, how RAG is working on top of GPT, even if GPT is having its own knowledge source,
Right.
and in which scenarios the knowledge source will be utilized basically. So again, whether we want that knowledge source to be utilized or not, that's the question. So we have a control, which we do not have when we are using only GPT, which we do not have. I cannot restrict GPT to use its knowledge base when I'm only inferencing. I can say that, hey, don't use data from Wikipedia, or hey, don't use data from untrusted sources, because it is mean to use that data and re-rank and rebuild the answers. So here, when I'm using RAG, I have a control over the response which is generated by model. So what RAG architecture will do, it will build the context by retrieving those top K chunks. And here now lies the beauty of my prompt engineering. In my prompt, I'll have to be very specific that should it use only the data from the context, and if the data is not available in that context, it should not answer. So in the prompt, I'll mention that if you do not find the data of XYZ patient in the context, please say that data is not available to answer your question. So here now I am restricting model to use its own knowledge base. And here GPT will not use, if I'm using GPT for building this RAG, GPT will not use its own knowledge base to answer that what are the treatments for the cardiovascular diseases, or what are the treatment when such a patient with such complex such symptoms are posed, right? So here your prompt, you need to have a very good hand on writing the prompt. You can even say that the chunk which are retrieved, summarize those chunks and give it to me. So it may be a extractive summary, or it can be a generative summary. Extractive summary wherein the sentences will be taken only from the chunk, and generative summary wherein the sentences will be taken from the chunk and regenerated. It will regenerate the new sentences which is completely in line with the text, but will not be 100% same as that of the text, right? So here, as you have rightly mentioned, it is working on top of it, and GPT or the LLMs are used only for language generation purpose and not for knowledge here.
True,
I
true,
hope
true.
that answers your
Yes,
question.
yes. Answered. Like, but like there is one a doubt. Like pre-train training, we are you're uttering those words, and you are like taking the context of pre-training. So what is that
Yeah,
in this case then? Pre-training.
pre-training. Sorry. So pre-training is there only during the initial uh, building of the LLM, wherein it is only taking the raw data and understanding the language. So, okay, what is the next token prediction from this language? It is trying to understand that what if the verb is there? What if the noun is there? What if, I'm sorry, what is the sentence structure? So it is understanding semantically and lexically. And pre-training will not so pre-training will be useful only in the language understanding phase. And here, when we are inferencing the model, so basically in the RAG architecture, we are inferencing the model. As we are inferencing, the pre-training has happened way before it, and the model is pre-trained and understood only the language. So now this model will not be a model which is pre-trained for English, will not be able to understand Portuguese, right? So if you ask a Portuguese question, here the model will not understand anything. You need to go back and choose a model which is pre-trained to understand Portuguese language.
Okay,
Uh,
okay. Good. Got the answer.
okay. Thank you. I'm happy. Okay. So any other question? Okay. So if no more, let me quickly check something in the message if there's a question. Okay. No problem.
Participant, any question from your side?
No problem, no problem. If there are any
Yes.
questions, feel free to put it in the chat and I'll answer. I'll try to answer if I can. Okay, so now going back to which type of vector DBs are available. Can I use the traditional SQL relational databases? So of course not, because we are storing vectors here. So there are specific databases which are available, which can store, index the vector data. So there are vector databases, there are graph databases. LangGraph is working brilliantly using the graph databases. And there can be databases wherein it is not only storing, but it is also giving you indexing facilities. It is also giving you RAG framework altogether, like Snowflake is there, Elasticsearches are there. These are not only the databases, but they are also giving you a framework wherein you just need to plug and play, give your data, use their architecture, use their framework, and everything will be taken care by their frameworks. Depending on what kind of data you are using, there was one application wherein we were trying to recommend documents to the students. So these were like remedials. So if a student is not doing good in a particular area, then we had built an application which will give them remedial resources. So suppose student is not doing good in let's say queue. So to understand queue, it may need to, let's say circular queue, it may need to understand the basics of pointer. So these documents, the pointer, stack, and queue are connected to each other, and this relationship between the chunks should be stored somewhere when you are storing the embeddings. So that can be done using graph databases. Okay, so LangGraph is a framework which is very much suitable for such applications wherein your data is diverse, still it is linked, which is the beauty of the data in any uh, machine in any basically AI field basically. So here these databases are not only for storing the embeddings, but are also capable of information retrieval. Okay, so be it a vector DB or be it a graph DB. And there are regular SQL databases, because nowadays you must have seen that there are text to SQL models which are available. So your data can be the text to SQL model will give you the SQL query from the text, and then you can run that query directly on your SQL databases and retrieve the data, specifically in the banking domain. I have seen these applications are being used a lot. Okay, so this is about the databases, and I'll move towards the frameworks which are available. Haystack
Excuse me,
framework
ma'am.
is, yeah, sure.
One question is that in RAG architecture, one model is there that is encoder.
Yeah.
So what exactly
So
the process will be done in that encoder? Whether that
yeah.
message or whether that suppose patient data is stored in database that is encrypted or what?
So this is encoded data, ma'am, as I explained earlier as well. Let's say patient electronic medical records
So
are
that
there.
a textual data will be converted in any other format or what?
That's what
In
I'm
that
trying to tell
encoder
you.
model.
Yeah. That's what I'm trying to tell you, ma'am. So the PDFs, let's say patient records will be read here, it will be splitted, and those chunks are converted into vectors, so numbers. It will be converted into numbers in vectors, and those vectors will be stored in the database. So converting text into vector is the job of encoder model. So if I'm saying that I am taking a walk near a river bank, I am going to bank to deposit a money. The bank keyword which is there in both the sentences is, even if the keyword is same, the meaning is totally different here, right? So depending on which encoder model I'm using, it will convert that, it will justify the conversion of text to vector. So if I'm using a generic model, both the banks will get converted into same vector, which is wrong. But if I'm using domain specific model, let's say finance, if I'm using Finbird here, Finbird will understand that river bank vector should be different, and finance bank vector should be different. And then it will create two different embeddings for it. So this is the job of the encoder model, to convert the data into vector which are context relevant vectors. Hope that answered your question.
Yeah. Yeah, ma'am. Thank you.
Okay, so yeah, so different architectures and frameworks are there: Haystack, Rackflow, Textile, and Flash RAG. There are many. I haven't used all of them. We usually build RAG from scratch, but have some experience with Haystack and some with Flash RAG. Works better. Um, it is for non-technical people. It is for people who just want to use drag and drop and populate the architecture instead of build it from scratch. It is very difficult to have a control over, let's say I want to change my re-ranking strategy, if I want to change my chunking strategy, or if I want to experiment little with the synthesis component, then it will be difficult, not impossible, but it will be difficult to do so with these frameworks. You need to understand the framework, you need to understand the complexity of the framework, get into it, and then basically play with the components, right? Yeah. Okay, so the question is, can we use this to generate videos? So if you are using vision models, so depending on which type of model, so here I'm using, so which type of LLM you are using? So here we are using a large language model. Where is that? Okay. Yeah, this one. So which LLM you are using here, depending on that. So if you use a vision model here, that model or multimodal like GPT now, GPT 4.0 and beyond, there are multimodal models available. So you can use those models, which from the prompt, it will be able to generate the video, image, table, whatever you want. Okay, so it depends on the model in the synthesis component or synthesis phase, basically. Question. Okay, yeah. So now I'll take you through how can we improve the RAG. Okay, so now I said that question, user will ask a question. So user query is there. Here it will be embedded. But if I'm not a expert in that domain, I may ask wrong question as well. Like, uh, what are the types of vaccinations which are available for, let's say, HPV? That's the question. But maybe this is not the way with which the question should be asked. It can, so only a doctor can ask relevant question in the medical domain. This is not a generic statement, but most of the time, doctors will be able to ask better questions in the medical domain. But I'm not a medical professional. Still, I want to query and I want my answer to be perfect. So I'll give that job to LLM. I'll say that I am giving you a question, but this question may not be perfect. Will you help me in enriching the quality and the context of the question? Okay, and that is called as query augmentation or query expansion. In query augmentation, one query is taken by the user and it is rewritten. So one query is input, one query is output. This is rewritten based on the prompt. I may say that I'm not a healthcare professional, I don't understand the medical complexity. I may ask very mundane question. Please try to convert the question so that it will be a question which is asked by, let's say, nursing student or a medical student or a medical practicing professional, blah blah. So depending on your prompt, it will convert one query into another one well written query. There is a question expansion. So recently I worked on query expansion and it improved my model's accuracy of almost by 25%. So in the query expansion, now what happens, it will take one user query, it will divide that, it will regenerate multiple user queries which are in relevant with one user query, again relevant to the context. Okay, so if I'm saying what are the type of vaccinations for particular disease, then it may also give a query with, let's say, what are the types of diabetes, then what explain type 1 diabetes, explain type 2 diabetes. So more extended, more expanded query set will be given, and instead of firing only one query, these multiple queries will be used to retrieve the data. These multiple queries will be used, will be embedded. Semantic similarity of each query separately will be there. It will give you So if there are 4 queries, then 4 answers. So these 4 answers will be deduplicated because user is asking only one query. User should get only one response. User shouldn't get 4 response. User is not interested in the complexity of the model. User is only interested in good output. So we need not give 4 responses to the user and add complexity for him. Instead, deduplication should be performed and then deduplicated a top selected answer or merged answer again, depending on your prompt. So we are using LLM twice here. Once for augmenting or expanding the query set, and second for selecting or generating the response from the responses which are generated for all the different queries separately, right? And then this is very well worked. With my personal experience, I'm telling you, this worked really wonderfully for me, and it improved my model's accuracy a lot. But will it improve the retrieval accuracy, the chunk retrieval accuracy? What do you think? So if we go back to the architecture, this is working after this. Okay, so after this, I should say. It is working after this. So the top key relevant chunks remains the same. It is just trying to retrieve maximum possible information from this top key relevant. If you want to work on this side, if your model is not extracting the relevant, like if we are not teaching, if the student is not available with the entire material to be prepared for a particular topic, he will not be able to answer. So if the entire material is not only available, whatever intelligent prompting technique you may use, the answer is not going to be satisfying. So for that purpose, you need to go back and you need to work on your chunking strategies. Okay, so I'll show you those chunking strategies later. Okay, so this is how we can work with improving the RAG. And I'll quickly take you through the demo.
Hello, Pranita. I have one question.
Sure.
Dhanraj is here.
Yeah.
Can you go back to that framework?
Sure.
This one. Like as you said, it is related to only the chunks that you have retrieved already.
Yes.
But for example, if the retrieved k top chunks are not relevant, say for example, because it's a vectorization, it gives some answer. It has to give some answer. But those chunks are not relevant. For example, if user feels that whatever chunks, top key chunks, I'm prompting for getting the results, and those k chunks are not appropriate, as I'm not getting the answers, though I'm firing multiple queries.
Correct.
So what is the option for that one? Is there any method to improve?
Yeah. So that's what, again a brilliant question. That's what I was telling. That if student के पास उतना material ही नहीं है, उसको दिया ही नहीं है, तो how will he answer, right? So for that purpose, what we need to do is chunking. So we need to work on chunking strategies so that it will chunk better. Okay, so I'll take that also.
Okay. Semantic chunking, likewise.
Semantic, sentence, paragraph based, some other techniques, some other models.
Okay, so is
but you need to go back and improve this. So not only chunking, there are 2 ways where the improvement will be needed in that case. First thing, are you forming better chunks? Second thing, are you retrieving better chunks? Probability your similarity search needs to be revisited. Yes, only cosine similarity may not be.
Like for example, if you're taking cosine similarity or any say Earth-Moore distance function or if you want to find out the difference in vectors and similar chunks we're retrieving, but is there any option to give the feedback to the vector database or to the encoder model, like whatever k-top relevant chunks are there, but user is not satisfied, or the prompt generated, or sorry, answer generated for a given prompt is not proper. So is there any feedback loop available, or is there any possibility?
So that we need to do. We need to add. That's why I said that instead of using framework, we should build our RAG architecture from scratch. So I can add a feedback loop here. There is a RAGAS framework which is available, with which you can evaluate whether the top key relevant chunks which are retrieved are actually top key relevant or not. So if you are not satisfied with the chunks which are retrieved here, then and there you can give the feedback. And then again, this will happen. It will go back, it will again chunk, re-chunk, and then calculate the similarity again and give you new top K chunks. You need to keep on doing that till your metric response is satisfied.
Yes, yes, got it. Got the answer. Yes.
Okay. So I'll quickly take you through. Okay, the notebook, and I'll share this notebook with you, with everyone basically, so that you can do it along with me. On my GitHub, everything is available if anyone is interested. Okay, let me know if you have access to this collab notebook, and let me know if you are walking along with me through the notebook. Then I can take pauses till everyone is with me. So anyone walking along with me with the collab notebook? So I'll tell you the objective first. The objective here is that I have give me a second. Oh, it was already there. So objective is that this is my patient electronic medical record. Okay, and I haven't added the name here, but you can add the name and everything. So what are the chief complaint of this patient? What major surgical procedures were performed on this patient? The medical history of this patient, past medical history, social history, family history, and blah, blah. So there are details of the patient basically. This is one document. Like that, there can be multiple, okay, like 10,000 patients, so 10,000 documents can also be there. Okay, right now, as I'm using Collab Notebook, and so right now I'm playing with this one document basically. So what will I do first? The RAG, try to visualize the RAG architecture and revisit the RAG architecture. I need to take this document and I need to index the document in the vector DB, right? So before indexing, I need to chunk this document. So what will I do? To read these PDF files, I'll need a PyMU PDF or FitZ, the libraries which are available in Python. I'll install those libraries and I'll need a vector DB to store this. So I'm using ChromaDB. Feel free to use Phase as well. Phase is faster for the smaller documents, but for longer term, longer utilization, you can go for ChromaDB as well. Then LangChain framework for RAG architecture. Now I'm using the recursive character text splitter from LangChain for splitting the document. Okay, we can experiment with this, and the page for the different chunking techniques, I'll share that of course later. Okay, then I will also need to tokenize it. So the tokenizer should be relevant to the LLM which I'm using. So I'll need a transformer, sentence transformer as well for that. Now I'll load. So I have uploaded my EMR here and I am reading it with the PyMU PDF method. And the entire PDF is so here instead of reading a single PDF, you can simply add a loop here, and PyMU PDF facilitates you by reading multiple PDF at a time. So you can just give a path of a folder wherein multiple PDFs are residing. That can be done. Okay, and simply splitting, making the PDF ready so that I can use it later. Now for character splitter, recursive character splitter, I need to tell LangChain that on which character you want to split. So as it is a small document, I'm saying that split it on full stop or new line, not even a full stop. I'm saying paragraph level. So new line. So whenever there is a new line, consider it as a new chunk basically. And quite a mundane, traditional and naive technique, okay, but simple one. So just to understand how it works. So here I'm using that if there is a paragraph, that is double slash, or there is a single line, okay, or if these are the kind of separators, then split it. and the chunk size should be 1000. So until there are 1000 tokens in the chunk, it will try to find. Once if it finds once it finds slash these characters, it will basically split. And till 1000 tokens, if it doesn't find any of these, it will split at 1000. Okay, chunk overlap 50, so that two chunks will have something in common for the semantic bindness of those two chunks basically. And then now I'm using this character splitter for building the chunks. Now from this document, you can see it is not a /n character recursive character level chunking happens based on the sentences which are relevant to each, not relevant, but closer to each other. And then till the 1000 token, it will keep on putting the data in single chunk. So with this, we found that there are two chunks in this PDF. So this chunk is being divided into two different chunks, right? So basically, probably there are 2000 or less than 2000 tokens in this PDF, and that's why there are only two chunks available. Now, you can see that these are the chunks. So this is the first chunk, this is the second chunk. You can see that it is being broken in between. The sentence is being broken, right? So we are losing the context here, which is actually not good. And that's why we use semantic chunking or other chunking techniques. Okay. Now we also need to fit these chunks into our model window. So we will have to tokenize. Okay. So we need to go for token level splitting so that now as the character level splitting has happened, when the data is ready to be stored in the DB, now the data should be ready to be fed to the model for inferencing purpose. So we will go for token level chunking as well. And then there are three chunks for the same. So from the two, now there are three chunks so that it can be now fed in line with the tokenizer which we are using. And tokenizer should be used in line with the LLM which you are using. Okay, again, you can go to Hugging Face and you can find which tokenizer you want to use. Now here, I'm storing all this information into ChromaDB. So simple importing the methods, and here this method will generate and create an object of wherein I can store, and my vector DB is this. So this is my vector DB wherein this will be created on the database side and it will be stored. So you can see this is how the data is vectorized. Just for understanding purpose, I'm printing it. So you can see that the data is vectorized and it is stored now. Okay, and the total token chunks are this. Now, this is till what we are now. We are. I'll take you back to the architecture. So यहाँ तक हो गया vector DB. We have stored the data in the vector DB. Now we need to query. So we'll go back. So for query, we will, for the query, I'm using, first thing I need LLM. So which LLM? I'm using Mistral. Feel free to use any. Okay, I'm using Mistral 7B. You can use any model to which you have access. Just make sure that you have access to that model. You probably need to request access to the model, and you need to check whether you have access to the model. If you do not have access to the model, you need to request. Within 2 to 3 hours, that request gets granted basically. Okay, so I'm using Mistral. I need to follow the Mistral's prompt strategy. Okay. So you can go to, let's say, let me search how you can inference that model. So you can go to models. You can simply search for that model here. And this is the model page. Okay, so on this model page, it will give you how you can use the model. You just need to copy paste, nothing. Just copy paste this code and put it there. I have done the same. And then it will also give you what is the instruction format. So you need to follow this instruction format when you are querying this model. And yeah, this page will help you also know whether you have access to the model or not. So this is, I have followed the same instruction format, and my query, I'm writing a function so that I can call it again and again, and then inferencing. So calling the model, and here whatever response is given by the model. I'm not interested in, there are so many other parameters in the response. I'm only interested in the response to the question. Okay, it also tells you about whether it is toxic, whether it is good, how is the language, and there are other guarding parameters which will guard the response. We are not interested in that. So I am taking only the 0th token or 0th element from the response, which is nothing but the actual textual response to my query. Okay, so now which approach I'm using? I'm using the augmented query. So you can see I have written a function augment multiple query option. So here one query is being taken. In my prompt, I have written that, hey, give me 5 more or 4 more queries, something I've written here. I don't remember now. You can go through the prompt and you'll get to know. And it will generate those many number of queries from the query. So augment multiple queries. So when I'm doing this, I'm actually here. So here, augment relevant queries. Okay, so the queries are being augmented. Yeah, and the result again in the function only I have taken care of it that only unique results should be there, and it will give me each query result as well as the unique result. Okay, both, because I wanted to show you why after printing. That's why. So in the deduplication, only the unique results will be there. So when you are printing retrieved documents, it will give you all the retrieved document. When you are printing unique documents, it is giving you only the unique document which is relevant and given by the prompt. So single response, deduplicated response will be given. Okay, and now these are just the chunks, but I want these chunks to be re-ranked. Okay, so for re-ranking purpose, you can use any model, like I'm using cross encoder. You can use, again, free to use any other model for re-ranking. So I am saying that give me top 5 answers. Okay, top 5 relevant. So from the K answers, which are uh, K chunks which are available, I again more interested in 5. So it will give me topmost 5 pairs. And now my model is ready. My query is, please explain the medical history of the patient. Okay. Now I want to print the augmented queries. So from one query, what were the patient's previous medical condition? Did the patient have any allergies? When was the patient last hospitalized? What medication does the patient currently take? So my query is enriched here. If you're not interested in doing so, you can completely comment the augmented portion which I've added. Okay, and a single query you can fire. So enriched set of queries will be given, and it will try to give you much more information from the top K relevant chunks which are retrieved. So here you can see that it is giving me what are the chief complaint: headache and neck stiffness, major surgical or in invasive procedures, and it should be only from my document because I have prompted the model to do so. So you can see that it is being extracted from this document. If I would have added a name here, you can even add the name of a person, and you try to have multiple such documents here. Okay, multiple such documents, and just feel free to download this Colab notebook and experiment little more with this, or use this another query: what medicines are prescribed to the patient? In this case, it should give you only the list of medicines, these one: ampicillin, morphine, Tylenol. Okay, so it should only give you these list. So this is how it has become so easy nowadays for us to build an application. And to put it in production, just deploy it on Gradio. It is very easy to use Gradio. You can just deploy it and it can be accessed anywhere from the world. Okay. So this is the demo. Any question with the demo? Then I'll move further if there are no questions.
Participant, any question? Dear participant, if you have any questions on this.
Okay.
Please go ahead. There is no question.
Okay, great. So let's move.
Excuse me, madam.
Yeah.
मेरा
I have
जैसे
one.
तो ये बहुत revision है.
Hello.
Yes, go ahead.
Okay. Ma'am, I have one question regarding that example which you have given previously while embedding, generating the embedding vectors. So there you have given example related to one word called as bank. Okay. So you said that suppose that bank is the word which is appeared 2 times or maybe 3 times in a single sentence. Then I have one question regarding that is, while converting or getting the embedding vector for both the appearance of bank keyword, will get the same vector, embedding vector. So what kind of things we can apply there so that we can distinguish them? Can we consider there the context window size for identifying the first bank word and second bank word? For example, in the sentence, suppose I want to deposit check at the bank, but let's have a walk along the river bank. If this is the sentence, then so how we distinguish? Yes.
Okay. So it has got actually nothing to do with the context window. It is completely dependent on the encoder, which encoder you are using. So if you are using, let's say Finbert for encoding that document, then the sentence which you uttered just now, the bank keyword, the embeddings for both the keywords will be different here, because I want to deposit a check in the bank, but let's take a walk near the river bank before, along the river bank before that. So here the embeddings generated, if you are using BERT, then it may generate the number which is represented for first bank and second bank will be same. But if you are using Finbird, which is a fine-tuned financial encoder model, will generate different encodings for both. So I didn't understand that. What are you trying to ask me with the context window here? Because encoder will only encode. It will not do anything with the context.
Context. Okay.
Does that answer your question, ma'am?
Yes, ma'am.
Okay.
Yes.
Thank you.
Yeah.
Okay. So as earlier, sir was asking us that, hey, what if my retrieved top K chunks are not only good? So whatever intelligent prompting technique I may have used, this is not going to be helpful, because the knowledge is not being exposed to the LLM, right? So it will never do good. So how can I make sure that the retrieval of the chunk, how can I make sure the quality of the retrieval chunk basically? So that can be done by evaluating RAG at different points. So the first place would be evaluate your, let me take you back to the components. So evaluate your chunking strategy. This is the first place. Okay. Second, evaluate your indexing, whether indexing has happened properly or not. Third, evaluate your semantic search, whether it is doing a good job or not, or do you need to experiment with the similarity calculation as well. So these three evaluations will give you fair idea that whether the top K relevant chunks are actually relevant to the query or not. Okay. So for that purpose, how can I evaluate it? Okay, sorry, I thought there is some question. Okay, so for evaluating that, there are frameworks which are available. So like there are metrics. Context relevance is a metric. Whether the answer is faithful or groundedness of the answer, relevancy of the answer, relevancy of the context will evaluate chunking. Relevancy of the answer will evaluate your prompt. Answer faithfulness will evaluate K plus P, both. Okay. And the framework, as I mentioned earlier, RAGAS is very useful in evaluating the RAG architecture at these different levels, basically. Okay. Or you can have synthetic test data sets, ground truths, with the help of which you can say that, okay, I know the answer for the question from this context. Then calculate the Roosh score or calculate the word score for the answers, and then you can calculate the precision and recall, and then you can see whether it is working good or not. Or my favorite one, you can use LLM as a judge, but you can't rely on it because you need to use prompt chaining to implement LLM as a judge. Okay, that's a reliable one. Okay, so this is how you can evaluate it. What are the advantages? So we have seen that it is simple and efficient technique to extract the relevant information from the user document, okay, proprietary documents. Uniformity in data handling across retrieval and synthesis phases, because encoders, same tokenizers are being used. So we don't know which encoder is being used to encode GPT data, right? Whether I'll be able to use it or not. So here you have a complete control over it. Disadvantage, limited contextual understanding. As सर हैज मेंशन कि अगर स्टूडेंट को वो सिखाया ही नहीं है, स्टूडेंट के पास अगर वो डेटा ही नहीं है, हाउ ही और शी इज गोना आंसर, राइट? So limited contextual understanding. If my data is garbage, there will be garbage. The same ML rule gets applicable here as well. So as Dhanraj mentioned earlier, you need to work on the data side as well. It is potential for there is a potential for suboptimal responses as well. That not necessary you will be always happy with the response. You need to work a lot on improving it. Few of the improvement techniques which I have already discussed, and it is there on the Colab notebook as well. So feel free to use it and walk through it. So how can we optimize the RAG? Chunking techniques. You can use sentence based, but which one should be used when? So if you are building FAQs or short responses, then use the sentence based chunking. If you are using blog posts or articles or papers, then use paragraph based chunking. If you are you have a thematic research, like you are using books and books or a huge data, then it is better to use semantic chunking, a knowledge which is spreaded across your data set. So it is better to use semantic chunking. There are different NLP techniques which are available with which you can automate the chunking process as well, like tokenization, NER, topic modeling. There are n number of techniques which are available, but you need to be very sure whether those techniques are applicable to your use case or not, right? Yeah, so this is with these better chunking technique, you will find that the retrieval accuracy is improved, top K is improved, better contextualization has happened for the prompt, and it will efficiently index the data as well. Okay. For chunking, evaluating whether the chunking has happened properly or not, so you can evaluate the relevancy, the coherence, and contextual integrity of the chunks which are retrieved. Okay. And now this is all about what I actually wanted to discuss, but about the RAG. Okay, but are we happy with this? Like one madam mentioned that, can I generate video from it? Then I'm not happy if it is not able to generate the video from it. So then the next thing comes, which is multimodal RAG. So in multimodal, it is not only about the text, but it is also about the images, videos, tables, right? So here, when I'm performing the semantic similarity on this, so it should have a cute cat and image together, right? A cute puppy and a image together. So for this purpose, the encoders which we used in our Colab notebook are definitely not useful. So for that, what you need to do? You need to go for multimodal RAG pipeline. So I'll quickly in 2 minutes tell you what it is. There are two ways with which you can chunk. One, convert the multimodality into single modality and use it, or another, keep the modality as is and use different encoders. Like in my data, I have text, tables, and images. what will I do? I'll use a LLM here, which wasn't there earlier. Okay, in our LLMs was far in the RAG, but what will I do? I'll use a LLM and I'll use a vision model to give me the description of the image, give me the description of the table. And text is already a text. So description of the table is a text. Description of an image is also a text, and text is a text. So I'm converting this multimodality into single modality, which is called as a text. So here I have the table summary, image summary, and the text. Now the same pipeline which we built just now can be used, and then you can same pipeline can be used. Okay, you need to store the metadata along with it, so that in your response, if you want the images to be retrieved, if you want only the description of the images to be retrieved, the same pipeline which is there in the Colab notebook should work. Now, what if I want the images to be also included in the answer? Then this will not work. Then I need to preserve the multimodality. So what will I do? I'll take the text, the table. So I can use like table llama models are there which understand tables. I can use vision models which can understand images, and I'll perform encoding. So these embeddings will be stored, generated by 3 different embedding models. Okay, and then now you have vector 1, vector 2, vector 3. Now the data is converted into vectors. Now chunk it together. Now this chunking is again different. It's a different strategy, because you need to take care of this, that these are images and tables also along with it. So it's a beautiful technique of chunking here as well. But again, it takes time, and it will again take probably a 2-hour session later. And then you can store it in the vector store as these are vectors, and the RESTful pipeline will be good. Meta will be same. Metadata has to be stored. The images needs to be on the LLM side. You need to use a multimodal LLM so that it can understand the image data and generate the image data as well. Okay. So the question to your brain feed after this would be, can we improve LLM output by telling model what not to do? So already Dhanraj answered that yes, we can control the hallucination by telling that, hey, if you don't have a data in the available context, the question cannot be answered from the given context. Okay. How much you trust the factual answers from LLM? So how much you trust the factual answers? We don't trust actually. And that's why there are RAG. Okay. Can LLM outcome be improved only with effective prompting? So it can be, but we need something on top of it, which is actually a RAG architecture. So we actually tried answering these 3 questions. We actually tried discussing these 3 questions throughout our discussion today. Okay. So this is all about RAG. And I'll quickly tell you that there are agents which I'm not the expert in agent. So you are going to dive into agent on the last day of your FDP. So these are basically autonomously performing. These are the systems which will autonomously perform some task for you. They have the ability to reason, which is using the user query, ability to act, and ability to access memory. So kind of recommendation engines, personalized responses, doing something on behalf of you. Okay, but there are a lot of ethical and explainable concerns about it, and that's why there is a new field in responsible AI, which is for the people who want to get into PhD in Gen AI. My suggestion would be get into responsible AI. That how can we use these LLMs responsibly, or can I build a framework which will give me assurance that LLMs are being built responsibly. Okay, because the AI systems needs to be transparent, fair, empathetic, and robust. Okay, then it is considered a responsible system. So we need to define the responsible AI impact assessment policy. And a lot of work is going on here, and the doors for the research are open in this field basically. So as it was a FDP, I thought of giving you some takeaway for the people who want to get into Gen AI, but don't just want to imitate what other people are doing, but want to do something other than what is available there. So this is responsible AI for you people. Yeah. And thank you so much. I hope you all enjoyed the session as much as I enjoyed talking to you all. And if you have any questions, I'm open for the questions here.
So, ma'am, one more question is there.
in the chat. Okay.
Hello.
Yeah. I can hear you. Please go ahead.
If I want to go further in LLM as a research point of view, so what will be the scope for generative AI or what? How I proceed further with LLM?
Yeah.
If I want to
So
go
as I said,
research.
yeah. So as I said, being a system engineer, we should try more on the optimization side. We should try more on improving the outcome. We should try to come up with better chunking strategies. We should try to come up with more better evaluation metrics. So there are three major components where the research is going on. One is optimizing the Gen AI. Okay, so answer is there, but at what cost? And cost, resources, time, people, money. So if answer is at very much cost, then no, that's not a good answer. Okay, so optimize it that way, either resource, time, money, people. Second thing is trusting. So how can you make those systems more fair and transparent to the user? So you need to work on the side of retrieving the data, maintaining the metadata, storing that metadata, and making sure that the responses are being fetched from the factual sources. Okay. And third, till date, there are not enough metrics which will justify the tasks which are being done by LLMs. So evaluation is a major field of research in Gen AI. And the last one, which I mentioned, this is for management people, not for technical people, which is responsible AI. So these are different fields wherein the research is still happening, and still there is a huge scope for research.
Yeah. One more thing is, will there the requirement of GPU only for development of LLM, or normal processor can with normal processor can we develop?
Yeah, we can. There are CPU based systems. You can go for batch processing. There are architectures which are available. So with the help of CPU, but you need to be very patient with CPUs. It takes time. So, but Colab notebook is giving you 4-bit GPU. So I experiment a lot with Colab for my personal work.
Yeah.
So that works. Like the one which we executed today was Colab. And there are free NVIDIA also. If you are a faculty, you have so many resources available free of cost. So for faculty, for students, there are many resources which are available free of cost.
Okay, ma'am. Sure. Thank you, ma'am.
So if any question in the chat, I'll quickly check.
Thank you, ma'am.
Okay, thank you.
Yeah, I would like to request Professor Bharti Sahu ma'am to deliver the vote of thanks. All participants are requested to switch on the camera so that we can take the screenshot.
I'll stop sharing so that we can have all the participants on the screen. Yeah.
Pranita, there is one question. Pranita.
Yeah.
There is one question. Can you please highlight some? Let me read. Can you
research
please highlight?
Areas.
Can you please highlight some research areas in GenAI for technical people?
Yeah, so these are all the topics which I discussed are all for technical people, like responsible AI. I'm typing it in the chat. Responsible AI, I just answered the same question actually. Evaluation strategies are there. Then there are optimization methods needed. So these are, as per my knowledge, again, I'm not an expert in this field. And these are the areas basically wherein the research is still happening and there is a lot of scope. Okay, any other question? Yeah, thank you.
Yes, Bharti ma'am, please.
Good afternoon, everyone. On the behalf of this computer department, Dr. D.Y. Patil Institute of Technology, Pimpri, Pune, it is my proud privilege to propose the vote of thanks for this today's enlightening sessions. First and the foremost, I extend my heartfelt gratitude to our distinguished speaker, Ms. Pranita Mahajan, ma'am, for taking the time to join us and share your invaluable insights on RAG and RAG optimizations in healthcare domain. Your deep expertise and engaging presentations on the language generation models, chunks strategy, prompts, improvements of the RAG have truly inspired and enriched our faculty members and participants alike. The way you have connected theory with the real world applications was both informative and thought provoking. We are truly fortunate to have you with us today. Thank you for adding immense value to our academic ecosystem also. I also takes this opportunity to thank our management, Honorable Secretary Dr. Somnath Patil sir, our respected Dr. Dheeraj Agarwal sir, Director Central Corporate Relations, Dr. Nitin Sherje sir, Principal, and our Head of Department Dr. Vinod Kembone sir for their continuous supports and encouragements in organizing such impactful events. A special thanks to our faculty members and organizing committee whose efforts behind the scenes made today's sessions a smooth success. Lastly, I extend our sincere appreciation to our enthusiastic participants for their active participants and urge to learn. Your curiosity is what keeps such events meaningful. So let us take the inspirations from today's talk and apply it in our academic and professional pursuits with the renewable zeal. Once again, thank you all, and thank you, Ms. Pranita Majan, ma'am, for being with us today. Have a great day ahead.
Thank
Thank
you.
you,
Thank you
Dr.
so much.
Pranita, for sharing
Yeah.
the valuable insights, and really we are like very happy to understand what is RAG and what way we can train the models, basically specifically in RAG. Thanks for sharing your valuable time with all of us. Thank you very much.
Thank you. Thank you so much, everyone. Yeah, it's been
Yeah, really,
pleasure.
it's very inspiring session,
Yeah,
ma'am. Really, we understood what is the RAG and all optimizations.
Thank you. Thank you. I'm happy. And yeah, thank you so much, everyone, for your patience. And thank you, Dhanraj and committee, for inviting me and having this opportunity to interact with everyone. Have a great day. And please feel free to connect with me on my LinkedIn. Um, we can be in touch. Thank you.
Ma'am, the participants were asking for the PPT. So can you share us?
Yeah. I'll reply to the mail invite.
Yeah, sure, ma'am. Thank you, ma'am.
Thank you. Bye bye. Have a great day ahead. Bye.
Bye bye. Have a great day, ma'am.
Yes, we declare that session is over. Participants may leave the meeting. Thank you. Yeah, feedback link is shared in the chat box. Yeah, feedback and attendance link are saved. Participants can leave the meeting.
Ma'am, can you please share the link once again?
Even I am not able to trace where the link is. If you could please reshare it.